The next one is comprehension type question. Benzylic acid rearrangement. So the question is on rearrangement involves base catalyzed reaction of a diketone to a salt of 2-hydroxy carboxylic acid. That is the benzylic acid rearrangement which takes place on diketones in the presence of base catalyst to give hydroxy carboxylic acid. This reaction cannot be used for 1,2-diketones containing alpha methylene group because of competing aldol condensation. So not completing. So that is the comprehension given. Now in this case, what is X? Now here is once again we have a diketone, but the group here is nitrophenyl group and here is tolulyl group. Tolulyl group in other words. So the OH minus will attack where? This being NO2 strong electron withdrawing group, this carbonyl carbon becomes more positive. OH minus will attack on this carbon. So the product expected from the reaction is this 5NO2 is shifted and thereby we find 5CH3, 5NO2. So 5CH3, 5NO2 has come to the same carbon OH and C double bond OO minus. So C looks to be the answer. Let us see the mechanism. Thereby we can understand more clearly to check whether the answer C is right or not. So we are given here, this is one substrate on keto carbon here and on this it is this substrate. Now OH minus preferentially will attack this carbon because here nitro group is a strong electron withdrawing group. This becomes more positive carbon than this methyl group being less I effect group, electron releasing group. So electromeric effect takes place to give the first step as this is the 5NO2 and this is CO minus and here is the OH and then C double bond O 5CH3. This will come back and this 5NO2 will be shifted to this so that it becomes C double bond O OH and on this carbon as it is shifted here this pi electrons will shift here. So therefore O minus this 5CH3 is already there tolulyl group and this 5NO2 nitrophenyl group will come and now this H will shift here so that it will become C double bond O O minus and this becomes OH hydroxy group, this becomes 5CH3 and this is 5NO2. 2-hydroxy carboxylate is formed and you need to see that this is the carbon which is starred, this is the carbon which is starred onto which 5NO2 is shifted. Otherwise when you compare the answer B and C you get it out, both look alike. So what is the difference? Here it is the star marked carbon on which 5NO2 and 5CH3 are present, here without the star mark. We know that this 5NO2 as a whole is shifted to star marked carbon. Therefore C is the answer but not B. So indirectly you are asked to check whether this OH minus carbon attacks preferentially this carbon or this carbon. That is the main point.